Welcome to the DIY Honda Garage channel. This presentation addresses DTC P053F, indicating a fuel rail pressure performance issue for the Honda Civic model year 2016 to 2021. DTC stands for Diagnostic Trouble Code, which is utilized by diagnostic systems to identify malfunctions in various vehicle systems. The fuel rail pressure performance is critical for proper engine operation, as it ensures that the engine receives the correct amount of fuel for combustion. A malfunction can adversely affect engine performance, fuel efficiency, and emissions. The fuel system is composed of several components, including a high-pressure fuel pump, the fuel rail, and a fuel pressure sensor, all of which play pivotal roles in delivering fuel to the engine at the right pressure. It is important to approach troubleshooting systematically to ensure accurate diagnosis and repair. The DTC P053F refers specifically to concerns regarding the fuel rail pressure performance in a Honda Civic from 2016 to 2021. The fuel rail pressure sensor's role is to monitor the pressure of the fuel delivered to the engine. This sensor is typically located on the fuel rail, which distributes fuel to the engine's injectors. The high-pressure fuel pump is responsible for pumping fuel from the fuel tank to the fuel rail, providing the pressure needed to ensure proper fuel atomization. If these components malfunction, the performance of the engine can be affected significantly. A common practice when diagnosing this issue is to analyze the entire fuel delivery system. This includes checking the integrity of fuel lines, the fuel filter, and the fuel regulator. Identifying the root of the problem is essential in restoring functionality. There are several potential causes for the DTC P053F, starting with the obvious, the vehicle being out of fuel, which can lead to engine stalling and trigger this DTC. If a fuel leak occurs, this also would result in the same. The integrity of fuel lines must be inspected thoroughly to rule out any leaks. A malfunctioning fuel pump can result in inadequate fuel pressure being delivered to the engine, which again could lead to performance problems. Moreover, issues like a faulty fuel pressure sensor could incorrectly relay information about fuel pressure, leading to the illumination of the DTC. Prioritizing which issues to address based on the symptoms observed during diagnosis is crucial for efficiency. The symptoms associated with DTC P053F may vary, but commonly include engine stalling, which is typically indicative of insufficient fuel pressure. Drivers may also experience noticeable performance issues, such as lack of power or rough idling conditions. The check engine light will frequently activate as a result of this trouble code being stored in the vehicle's computer system. Additionally, poor fuel efficiency could be experienced due to the engine's struggle to maintain optimal performance levels. These symptoms can lead to further complications if not addressed, highlighting the importance of prompt diagnostic testing when this trouble code is present. Step 1 of troubleshooting DTC P053F involves initial diagnostic checks with a Honda Diagnostic System, HDS. First, record all onboard snapshots. This provides critical data on the vehicle's operating conditions when the DTC was triggered. The next step requires turning the ignition to the on position, followed by utilizing the HDS to clear the stored DTC. Clearing the code allows for a fresh start and helps to identify if the issue is persistent. It's vital to start the engine subsequently and hold the engine speed at 3,000 RPM without load until the radiator fan activates, before allowing it to return to idle. This step helps to stabilize conditions under which the fuel pressure can be tested accurately. In the second step of troubleshooting, a test drive is required to gather more data. Drive the vehicle for several minutes, ensuring to cover a range of speeds and engine loads that match the conditions in the previously recorded onboard snapshots. Key parameters to monitor include engine speed, vehicle speed, and sensor readings such as the manifold absolute pressure, MAP, sensor, and fuel pressure values from the direct injection system. After the test drive, use the HDS again to check for any pending or confirmed DTCs. If DTCs such as P0087, P0088, or P0089 are indicated, the issue likely repeats, and it is mandatory to move forward in the troubleshooting process. If not, it indicates an intermittent fault, which will require further inspection of critical components involved in the fuel delivery system. Step 3 focuses on the operation of the spill valve located in the high-pressure fuel pump. Start the engine and allow it to idle while listening for any unusual noise or vibrations emanating from the spill valve. This component is tasked with controlling fuel flow and releasing excess fuel pressure, which is critical for proper engine operation. Ensuring that the spill valve operates correctly is essential. If no noise or vibration is detected, it is indicative that the high-pressure fuel pump may need to be replaced. Recognizing this step ensures an efficient diagnosis by isolating the fuel pump's functionality early in the troubleshooting process. In this step, the fuel pressure sensor's operation is assessed. Start by turning off the vehicle's ignition and removing the PGM-FI main relay tube, which ensures that no fuel supply occurs when the engine is cranked. Start the engine and allow it to idle until it eventually stalls. After stalling, crank the engine several times to check the pressure conditions. Use the HDS to assess the readings of the fuel pressure converted from the pressure feedback PF sensor. Values should ideally be less than 2,000 kilopascal. However, it's acceptable for this threshold to reflect several hundred kilopascal. If these readings align with expectations, troubleshooting proceeds to the next step. Discrepancies may indicate that the fuel rail or sensor may need replacement. Step 5 requires another assessment of the fuel rail pressure sensor. Turn off the ignition, reinstall the PGM-FI main relay 2, and start the engine once more. It's vital to hold the engine speed at 3,000 RPM without load until the radiator fan engages, and then allow it to return to idle. Snap the throttle multiple times and check the readings from the HDS to evaluate the parameters noted in Step 4. Both the fuel pressure converted from the PF sensor and the direct injection system pressure should closely align, while the relief valve should indicate normal operation as well. If both values do not correlate, it implies that the fuel rail pressure sensor may require replacement. Discrepancies at this stage help in pinpointing the source of the problem for effective repairs. Step 6 necessitates a thorough examination of the fuel pressure, specifically on the low-pressure side of the system. It's imperative to check the fuel pressure using the appropriate testing equipment to establish whether it meets the required specifications. If the fuel pressure is satisfactory, it confirms that the low-pressure side is functioning properly, thus allowing further investigation into other components of the fuel system. However, if the readings are outside acceptable ranges, a detailed inspection of the fuel pump, fuel pressure regulator, fuel filter, and fuel lines is warranted. Identifying issues within these components can often resolve the underlying cause of the DTC P053F and restore proper system function. The final troubleshooting step focuses on the high-pressure fuel pump itself. Carefully remove the high-pressure fuel pump and conduct a thorough visual inspection of both the pump cam and the pump lifter for any signs of wear or damage. These components are critical as they drive the high-pressure fuel pump and ensure effective operation. If the pump components appear to be in good condition, it would indicate that the pump may require replacement. Conversely, if any damage is noted during the inspection, further checks on the associated cam should be conducted, potentially necessitating the replacement of the exhaust camshaft or the high-pressure fuel pump itself. Ensuring all parts are in working order is essential for optimizing fuel delivery performance. Once all identified repairs for DTC P053F have been conducted, it is vital to perform a final verification process. This involves rechecking for any stored DTCs using the Honda Diagnostic System, HDS, to ensure no codes are present. If DTC P053F or any other related codes return, it indicates that the repair has not resolved the issue, and additional troubleshooting steps may be necessary. Furthermore, conduct a road test to confirm that the vehicle operates properly under various driving conditions, while monitoring for any performance issues or abnormalities. Ensuring that the vehicle has returned to optimal operating conditions is crucial to validate the effectiveness of the repairs made. To prevent future occurrences of DTC P053F, regular fuel system maintenance is essential. Schedule routine checks to inspect the entire fuel system, including the high-pressure fuel pump, fuel rail, and associated sensors. Keeping an eye on fuel levels and ensuring that the tank is not allowed to run dry may significantly reduce the likelihood of this DTC being triggered again. Promptly addressing any signs of fuel leaks from hoses or fuel system components can further prevent fuel pressure-related issues. Overall, maintaining a proactive approach toward the fuel system will help ensure the long-term reliability and performance of the vehicle. In conclusion, addressing DTC P053F in the Honda Civic from 2016 to 2021 requires a thorough and systematic approach to troubleshooting. By understanding the components involved and the potential causes of the DTC, mechanics can diagnose and resolve issues effectively. Each troubleshooting step utilizes diagnostic equipment to gather critical information pertaining to the fuel system's performance. Ensuring all critical components, from sensors to pumps, are in good working order is imperative for optimal vehicle performance. Lastly, implementing preventive maintenance strategies will aid in extending the lifespan of the fuel system and minimize the risk of encountering this DTC in the future. Please like and subscribe to the channel. See you next time.